Hello students, in this session we will discuss moment area method. We start with introduction of moment area method and then we will discuss moment area theorem 1 and 2. After that we will solve a numerical to calculate slope and deflection of cantilever beam which is carrying point load only. So let's start with introduction of moment area method. Moment area method is used to determine slope and deflection of a beam and the method was developed by Charles Green. The method is most convenient for cantilever beam in which slope at fixed end is 0. It is also convenient for simply supported beam in which slope at mid-span is 0 and beams fixed at both ends in which slope at each end is 0. Now, moment area method is based on moment area theorem 1 and 2, which is developed by Moore. So, let's discuss moment area theorem. So, here in this figure, elastic curve AB represent part of deflected form of a beam of uniform section. Line AB dash and BB dash are tangents from point A and from point B respectively, and intersection of these tangents represent slope theta. Line BB dash is a deflection at point B. Now, moment area theorem 1 is used to calculate slope, and it states that the change of slope between 2 points on an elastic curve is equal to net area of M upon EI diagram between these points. And here is the equation for theorem 1. Theta, which is slope, is equal to integration A to B M upon EI into dx. In simple word, for calculation of the slope, we need to calculate net area of M upon EI diagram between point A and B. Okay. Now, moment area theorem 2. It states that the displacement of point B from the tangent at A is equal to moment of M upon EI diagram between point A and B taken about B. And here is the equation for theorem 2. BB dash, which is deflection, is equal to integration A to B M upon EI into x into dx. So, moment area theorem 2 is used for calculation of deflection. And in simple word, if I want to calculate deflection at point B, then I need to calculate moment of M upon EI diagram between point A to B, and the moment is taken from point B. Okay. Now, before calculating numerical, it is very important for us to discuss area and position of center of gravity of three different shapes. For calculation of numerical, it is very important. So here, shape number 1 is a right angle triangle, and area of right angle triangle is 1/2 BH, where B is base of triangle and H is height of triangle. Now, CG of this triangle will be at a distance of 2/3 into B from point A and 1/3 into B from point B. Okay. Now, here is the parabola shape. Area of this parabola is 1/3 BH. Again, B is the base and H is height of parabola. Now, CG of this parabola will be at a distance 3/4 into B from point A and 1/4 into B from point B. And in this type of the parabola, area is equal to 2/3 into BH. And CG of this parabola will be at a distance of 5/8 into B from point A and 3/8 into B from point B. Again, area and position of CG of this three shape is very important for calculation of numerical. So, let's solve a numerical. Here, we need to determine slope and deflection at free end of cantilever beam. It means here we need to calculate slope at point B and deflection at point B using moment area method. Given value of Ixx, which is moment of inertia about xx axis, it is 6 into 10 raised to 7 mm raised to 4. And capital E is Young's modulus of elasticity. It is 2 into 10 raised to 5 Newton per mm square. Here, this cantilever beam has one point load of 30 kilonewton at point B and total length of the beam is 2 meter. Now, these are the steps that we will follow for calculation of numerical. First of all, we will calculate moment and then we will draw bending moment diagram and then we will convert bending moment diagram into M upon EI diagram. In step number 2, we will calculate slope and in step number 3, we will calculate deflection. So, let's start with step number 1. Here we will calculate moment at point B and at point A. We know that moment at free end of cantilever beam is always 0. So moment at B will be 0. Now let's calculate moment at point A. Here we are calculating moment from left hand side. So while calculating moment from left hand side, we will consider all clockwise moment as negative and all anti-clockwise moment as positive. Here this 30 kilonewton load will generate clockwise moment about point A. Here the generated moment is clockwise and we are considering moment from left hand side, so we will consider it as negative. And moment of this point load about point A is equal to load, which is 30 kilonewton, into distance of line of action of this load from point A, which is 2 meter. So, moment of this 30 kilonewton load about point A is equal to 30 into 2. So, total moment at point A is equal to minus 60 kilonewton into meter. Now, let's draw bending moment diagram. So, here is the bending moment diagram. At point B, moment is 0 and at point A, moment is 60 kilonewton into meter. Negative sign for this clockwise moment. Now, in between point A and B, there is no load. So, bending moment diagram is straight inclined line. This is bending moment diagram. Now, we will convert this bending moment diagram into M upon EI diagram. So, at point B, moment is 0. So, M upon EI will also be 0. So, here at point B, M upon EI is 0. Now, at point A, moment is 60 kilonewton into meter. So, if I calculate M upon EI, then it will be 60 upon EI. Remember one thing, M upon EI diagram is similar to bending moment diagram, but in M upon EI diagram, instead of considering only moment M, we are considering M upon EI. Here again in between point A and B there is no load, so bending moment line will be straight inclined line. Now let's move to step number 2. In step number 2 we will calculate slope at point B and I denote it as theta B. For calculation of the slope we need to apply moment area theorem 1. And as per moment area theorem 1, for calculation of slope at point B, we need to calculate area of M upon EI diagram first. So, equation for calculating theta B is equal to minus area of M upon EI diagram between point B and A. Okay, here in this M upon EI diagram, area between point A to B is area of this triangle, and we know that area of triangle is 1/2 BH. Okay, so it is 1/2, base of triangle is 2 meter and height of this triangle is 60 upon EI. So theta B is 60 kilonewton into meter square upon EI. Now, value of I is in unit mm raised to 4 and E in unit Newton per mm square. So, we need to convert this 60 kilonewton into meter square into Newton into mm square. and for that we need to multiply 60 with 10 raised to 9. So after multiplications of 60 with 10 raised to 9, the unit will be Newton into mm square. Now value of E, which is given data, 2 into 10 raised to 5 Newton per mm square, and value of I is 6 into 10 raised to 7. So I am getting value of theta B is 0.005 radian, and in degree it is 0.286. Now let's calculate deflection at point B. Okay, and for calculation of deflection we need to apply moment area theorem 2. And as per moment area theorem 2, if we need to calculate deflection at point B, then we need to calculate moment of m upon EI diagram about point B. So here is the equation to calculate deflection at B. I denote it at YB. So YB is equal to minus moment of m upon EI diagram between point B and A about point B. Here moment of m upon EI diagram about point B is nothing but area of this triangle into distance of CG of this triangle from point B. And area of triangle is 1/2 BH, which is equal to 1/2 2 into 60 upon EI. And distance of CG of this triangle from point B will be at a distance of 2 by 3 into 2. Okay, already discussed this. So we are getting YB is equal to 80 kilonewton into meter cube upon EI, and I need to convert it into Newton into mm cube. So I need to multiply 80 with 10 raised to 12. Value of E, which is given, 2 into 10 raised to 5, and I, which is also given, which is 6 into 10 raised to 7. So I am getting value of YB is equal to 6.67 mm. Value of YB means deflection at point B is positive. So we can say that the deflection is in downward direction. Okay, so here from this figure you can also see that because of this 30 kilonewton load, the cantilever beam will deflect like this, and here at this point we are getting deflection maximum, which is YB. Okay, this is end of this session. Thank you.